Okay, while I was waiting for things to upload, I went ahead and put those vertical asymptotes on at 4 and -4. Now remember, your last step is to plug in points on every side of the asymptote. So I'm going to start actually with that middle section and plug in 0. If I plug in 0, I get 4 times 0 squared over, and it doesn't really matter, but 2 times 0 minus 4 times 0 plus 4, and I get 0. So that means that this part of the graph is down below our asymptote. Then our, if we plug in, we got to be greater than 4. So if we plug in 5, we're going to get 4 times 5 squared over 2 times 5 minus 1 times 5 plus 1, which gives us 100 over 42, which is bigger than 2. So we're going to be up here. And then if we plug in -5, we're going to get pretty much the same thing because 5 squared and -5 squared are the same. So we are going to be up here. So that's what that looks like. Okay, for 11 through 14, we are simplifying the rational expressions, which means that your very first step is to factor. Factor. That's why we spent a whole day just reviewing factoring. So if I factor the top of this, I get x minus 3, x plus 3, x minus 5. And on the bottom, I get x minus 5 and x minus 5. So our simplification of this rational expression, those cancel, so we get x plus 3 over x minus 5. Now the other part of this, we'll go all Christmassy here, is it says state any restrictions on the variable. To do that, you have to go back to your original. And it just so happens that our denominator in the original is exactly the same. So our restrictions are that x cannot equal 5. Those restrictions happen when you set the denominator equal to 0. So x minus 5 equals 0. So x equals 5. That's where our asymptote's going to be. Okay, for 12, this simplification takes it way back to like last unit, where we're just going to subtract, add and subtract our exponents here. So 25 over 50 puts a 2 in the bottom. We're going to get g cubed on top and h cubed on top. And then again, with our restrictions, we want to look at what those variables in the denominator cannot equal. So g cannot be 0 and h cannot be 0. Okay, for number 13, we're going to factor before we multiply. So we get x minus 2, x plus 2 over x plus 3, x plus 1. Then we have x plus 3 and x plus 2. Now, that being said, we can cross-cancel those and cross-cancel those so that our final simplification is x minus 2 over x plus 1. Then we go back to the originals that we had for our restrictions. X cannot equal 3, -1, or -2. Okay, 14. We're going to factor first. Y minus 3, y plus 3 over y plus 10, y minus 5. And then I'm going to go ahead and change this to multiplication and flip it. Y minus 5, y minus 3. And I'm actually going to take into account our restrictions first. Y cannot equal -10, 5, or 3. And then I would also look at this one, and that one says that y can't equal 5 either. But we already have that down here. So it's fine to just leave that in 1. Now we will simplify y minus 3, y minus 3, y minus 5, y minus 5, and our simplification is y plus 3 over y plus 10. Okay, finally, this was supposed to be multiplication. This is a typo. So if we change that to multiplication, how are we going to handle this? Well, this is multiplication and division all together. So what we're going to do first is we're going to multiply, well, again, I'm going to set our restrictions. So x cannot be 0, -1, and y can also not be 0 because it's down here in that denominator. Then I am going to multiply and simplify. So I'm going to get 2 over x times x plus 1 over 1 over y. And then we have to keep change flip. So 2 over x times x plus 1 times y over 1 gives me 2y over x times x plus 1. And that is our final answer. I should have done that other stuff in black, but you get the idea. So there is your study guide. Come with questions to class before the test, and we will get it done.